Okay, so we're going to have a look at another electromagnetics question. We're told to make a table to show how projectile motion is similar to motion of a charged particle in a field. So we'll draw a little table with our projectile motion formulas, and then we'll draw a little table with our charged particle formulas, and then we'll compare them. So here we have accelerations, and we'll have the accelerations in x and in y. We'll have the velocities in x and y, and then we'll have the positions in x and y. So acceleration in x is 0. Acceleration in y is gravity, which is minus 9.8 approximately. The velocity of projectile, so this is the projectiles. Velocity is just whatever the initial velocity is. So this is velocity initial in the x direction. The velocity in y is minus 9.8 times time plus the velocity initial in y. Then the position is the velocity initial in x times time plus the starting x position. The position in y is minus 4.9 times time squared plus the velocity initial in y times time plus the y starting position. So this is a table that roughly represents how projectile motion works, given that the only acceleration is gravity. So now we're going to do one for charged particle. So this is for charged particle. Make this a little wider, so I'll give myself a little bit more space when I'm writing these. So again, we're going to have x and y. We're going to have acceleration. We're going to have velocity. We're going to have position. So we have acceleration, velocity, position. And then we have for x, and then we have for y. This is a little bit more complicated because the acceleration in x or the acceleration in y depends on how the field is oriented, and it depends on the charge of the particle. So if we assume in a very basic case that the acceleration from the field is pulling downwards, then we will get an acceleration in y, and the value of the acceleration in y will be something like minus QE over m. So this will be some acceleration downwards in y. And I've made it negative to show that it's downwards. It depends what the particle is, it depends what the field is as to whether it would be positive or negative. I've just chosen negative here. And the reason I've chosen negative is to show the similarities between projectile motion. Projectile motion has a negative y. Here, when we're dealing with fields, charged particles and uniform electric fields, we can have a negative y, right? We can have a constant here. The x could be some other value, and y could be 0. The y could be some value. There could be field in both of them, depending on how the field is oriented. But we're going to say x is 0. This means the velocity in x is just going to be the initial velocity in x. The velocity in y will be minus QE on m times time plus the initial velocity in y. Then the position for x will be the initial velocity in x times time plus the starting position for x. Then for y, we will have negative QE on 2m times time squared plus the initial velocity in y times time plus the y starting position. So you can see that these are very similar in many cases. Right? Very similar. And this is essentially what we're trying to show with this question. We're trying to show that the formulas for projectile motion are very similar to the formulas for the motion of a charged particle in a field. Right? These are incredibly similar, and we model them using incredibly similar formulas.